Hello friends, myself Shubhangi Bakal, and today I will tell you about what is naming in distributed databases. What is a name? Name is usually a string of bits or characters. We need names in a computer system to refer to and operate on entities such as host, printers, disk and files. To operate on an entity, we first need to access it. And how can we access an entity? We must know its identifier or its name. To obtain an entity's access point, we need either address or its name or any unique identifier. Uh, we need entity's access point for running server processes. Its transport level address serves as its access point. So how about use an address as the name to refer to an entity? Using addresses like its TCP address can be very it can be very confusing to remember such use addresses that are numbers. For example, here the address, TCP address like 129 dot dot dot, it refers to our department FTP service. Or how if we use numbers to refer to any person? It will be very complex and confusing to remember persons by their numbers. So using address to refer to an entity is inflexible, it's unfriendly, and what in case if the person wants to change its number? An entity changes address, and address reassigned to another entity. An entity can have more than one address, that is more than one access point, which so in such a case, which one to use as a reference? Easier and more flexible solution is to use location independent names. A special type of name is an identifier. We know that an identifier, it uniquely identifies an entity, and uh, no two entities can have the same identifier. So each entity is referred to by at most one identifier. An identifier always refers to the same entity. What could serve as a person's identifier? A person's identifier can be its name or its address, its habits, or friends, etc. Name types. There are three name types. The first one is identifier, address, or any human friendly name. Identifier is unambiguously refers to an entity. Address can be any access points in numbers, and human friendly name is any name which can be used by humans, often a character string, like my name Shubhangi. What is a naming system? In distributed databases, name system maintains a name to address binding to resolve name or identifier to address. In naming system, it maintains a collection of data that can be used to uniquely identify an entity. The implementation of naming system in distributed and non-distributed systems are quite different. Say how to locate a process in a uniprocessor system. In uniprocessor system, its operating system have a process table where the process table have a list of processes and its corresponding process IDs. These process IDs are used to uniquely identify a unique process. For example, the process uh, 1 has a PID like 101, and 101 can be only can only refer to the process 1 and not process 2. There are three types of naming system. First one is a flat naming. Flat naming, it resolves identifiers to addresses. Second one is the structured naming. In structured naming, the human-friendly names are resolved to addresses. The third is attribute-based naming. That in attribute-based naming, the descriptive functions are used as an addresses or as an identifier. In flat naming, uh, there are following solutions. The first is the simple solution. Simple solution consists of broadcasting or forwarding the pointers. The second solution is the home-based solution. The next is hierarchical, and finally the distributed hash tables. Let's see the first one. It's in simple solutions, the broadcasting. For example, if there are three machines, and if the first machine it need the address of the entity A, so it will simply broadcast a request to all the machines. All the machine will receive the request, but only the entity A it will reply to the request with its address, and all other remaining machines will just ignore the request. This is broadcasting. Broadcasting is not suitable for larger networks because the bandwidth is wasted and the other hosts are interrupted for no reason. The next is forwarding pointers. A forwarding pointer is a popular method to locate mobile entities. Whenever an entity moves from A to B, it leaves a pointer to B at A, like the link. Simple is using traditional naming service to locate to A and then follow the pointer chain. Uh, Example is the postal service. If one person moves from Florida to Virginia, it this figure it shows the principle of forwarding pointer using the client stub server stub pairs. The process the Each process has a client stubs, that is CS. Process 1's client stub, it has intercommunication with process 3's server stub. Process 2's client stub also have intercommunication to the process 3's server stub. Then the process 3 has a local invocation. Process 3 has an identical client club, and process 4 has an identical server stub. So the process 3's server stub has an intercommunication with the process 4's server stub. And finally the process 4 has its object. So all these processes are interconnected through links. That is forwarding pointers. Forwarding pointers is expensive if chain gets too large. It cannot be used for large systems. And what if a pointer to any process is lost? If any process lost its pointer, then it can become an orphan process. Comparison between broadcasting and forwarding pointers. Broadcasting have scalability problems, uh, and it has efficiency problems in large scale system as the bandwidth is wasted. Whereas in forwarding pointers, it have geographically scalability problems, as if long chains are formed, then it would be bulky and have a performance problem, and it is prone to failure if any chain gets lost. The other approaches are home based approaches. The home location is popular for supporting mobile entities in large scale networks, as our mobile communication centers have home location registry that have the identify uniquely identified our mobile numbers. And also it keeps the home location registry also keeps track of the current location of the mobiles. The next is the hierarchical approaches. The figure shows the hierarchical organization of a location service into domains, each having an associated directory node. Thank you.